Let's look at how D-glucose forms its ring formation. So on the left-hand side of the slide, we have the Fischer projection of glucose, and C1 is our carbonyl carbon, so it has this aldehyde functional group. C1 is also known as the anomeric carbon, and in the Fischer projection, it is not chiral. Then we have C2, C3, C4, C5, which are the chiral centers in this Fischer projection, and then C6. So when we form the ring, our anomeric carbon, C1, is going to form a hemiacetal connection with the oxygen from the hydroxyl group or the alcohol functional group on C5. And this hydrogen on the alcohol functional group is going to bond to this carbonyl oxygen to form a new alcohol group. So everything that is on the left-hand side in terms of our chiral carbons, what is on the left-hand side is going to be above the ring. So C2 has hydrogen on the left. Here's C2 in the ring. Hydrogen is above. C3 has hydroxyl on the ring on the left-hand side, and in the ring, hydroxyl is above. C4 has hydrogen on the left, and in the ring, hydrogen is above. And then C5 is actually our exception because C6 is what's going to be above the ring. Okay, so now let's look at our anomeric carbon. Our anomeric carbon is going to bond with a C5 oxygen and will have a six-membered ring where this oxygen from the C5 alcohol group is going to be in the ring. The hydroxyl group that forms on the carbonyl oxygen, right here, can either be above or below the ring. And if that hydroxyl group is above the ring, that's what's known as beta D-glucose. And if the hydroxyl is below the ring, then that's what's known as alpha D-glucose. So for the alpha form, the 6-carbon and the hydroxyl group on the anomeric carbon are on opposite sides of the ring. And for the beta, the hydroxyl group on the anomeric carbon is on the same side as the ring as the C6. So in any monosaccharide, the carbonyl carbon that reacts to form the hemiacetal bond is referred to as the anomeric carbon. And that hydroxyl group on the anomeric carbon, as we said, can be below the plane or above the plane. And these two are known as anomers, and they are interconvertible.